I'm going to put a print statement here that would print that same ASCII art as we've had basically after every single input. And then of course I'm just going to hit an enter just to give some space because we're going to be adding code blocks in here. So what I want to do is I want to use a for loop to go through all the characters in this chemical compound that they are entering. And again, remember the process is that we have to split all of these elements into to be all separate, but we also have to know if they're entering a chemical compound where there is a two-lettered element as opposed to one. So Al is not the same as H. Al is aluminum, H is hydrogen, H is a single letter which represents an element, and Al is a double lettered or is containing two letters which just represents still an element. So we have to detect that so we can make the system detect that so it can properly split where necessary a two-lettered element as opposed to a single element. So we're going to use a for loop to do this. I'm going to say for C in compound. It's going to go through all what they've entered in their compound, and then we're going to do the splitting part. So we're going to use that C dot is upper. We've learned about this upper method, which checks if something's in uppercase, and we want to know if the first letter written is in uppercase and if the second letter written is in lowercase. That's what we're going to do, and if that's the case, then we're going to join those two together because that just represents one single element. So we're going to say and is the compound, and we have to get the index position. So remember, the compound is what the user is entering. So we're checking to see if the first thing detected in this compound, the first character, is it in uppercase? And obviously that means is it a letter? And is that letter in uppercase? Then we're detecting the index position of that letter so we can determine if the next thing to it that precedes it is that also a letter but in lowercase. And if that's the case, it means that these are together and they are representing one element. So we're going to use this compound and we're going to find the index position of this particular letter that is in uppercase. So we're saying dot index of C, because that's the first letter detected in uppercase. We're going to find its index position and we're going to add +1. What does that mean? It means looking at what comes after it, and we're checking is that in lowercase. So we're going to say dot is lower. And if that's the case, if the first letter is in uppercase and the second letter is in lowercase, so that's what we're doing here, checking if the first letter, right, is in uppercase and the second letter is in lowercase. So this is important to know how it's working, so that you understand what goes on and you understand how it's supposed to work. So basically that's just what we're doing, is checking to see that the first letter is in uppercase and the second letter is in lowercase. Now, if that's the case, we're going to use this join. I'm going to use join, or you can use join one, whichever one you want to use. We've created two joins, remember, in the beginning of our program that we're basically using to join letters. The point of join is just to act as a joiner, like its name, and it's just going to be acting as a glue to join letters together, or to just join the same symbols and letters the users entered to display as a chemical compound. So here we want to use the join. I'm going to use join to basically join the C. So I'm going to say join equal C, and I'm just going to say plus. And what are we joining it to? We're joining it to what comes after it, because C is in uppercase. We've confirmed that with that if statement. And what comes after it is in lowercase. So we're joining them together to symbolize as one element in case if the user entered something as MG in the beginning, or AL or AG, and there's so many two-lettered elements. So that's what this would detect, and it would join properly. So as you can see here, we're joining it with the compound dot index of C. So of that letter, like what's the index position, and +1, which means get what comes after it, since it's in lowercase, and we're joining it. Now we have to confirm with the computer, with the compiler, making sure that this join is actually in the periodic table, because now that we've actually created this element by joining the first and the second letters together, which are in upper and lowercase, we want to check, is this a valid element? Have they entered something that's valid in the periodic table? So we're going to say if join in elements, because we've already imported that library dot all symbols, guys. That's how we do it to check if that is existing in the periodic table. So you're going to check if the element, okay, exists in the periodic table. So remember that this would be this statement here, which I forgot to indicate with a comment, relates to elements like MG, for example, SO4. In that situation, you can see that the first letter is uppercase, and the one that comes after it, which is this part that we've done right here, is lowercase. So hence, we're picking just the two letters, which is the MG, and we're checking to see if that MG does exist in the periodic table as an element. And if it does, then we're going to add it to that C list that we've already created. And also, before even adding it, we're actually not doing that now. We have to do a count, use the count variable, count +1. So remember that this program also is accepting a maximum of 3 elements in the compound to calculate the molecular weight for. So anytime we detect an element, when we go through the characters in this compound, we're doing count equals count +1. We're counting it as an element detected until to make sure that they don't enter more than 3 elements in a chemical compound. So that's what we're doing. And then now the else part is in case if this element that they've entered or the element that the system has kind of joined based on what they've entered does not exist. So we're going to say there's no such element like that. So we're going to print a message here saying such element does not exist, but I always like to print my messages that are errors in red color. So I'm going to copy this color code and paste it down here, because it basically just prints the message in in red color, sorry. So I'm going to print saying that such element does not exist in the periodic table. So such element does not exist in the periodic table, right? So we can tell them, please restart the program to start again. So I'm going to do a time.sleep and wait for about a second, and then print another message. And also, you can, of course, remember that if you want to do an ASCII art, you can go ahead and do so. It just makes everything look nicer. So you can go ahead and have something like this. And it just makes everything look good. So in the next part, after 1 second, I'm going to say, please restart the program again. So restart the program and enter the correct element. And then you can just do an exit so that they don't get to type anything anymore, and they're forced to restart again. So this is, of course, if the element that has been detected based on what the user has entered, and after the system has kind of joined the first and the second letter together, and it does detect that joining them, that element doesn't exist in the periodic table, then this message would be given. Now let's come down to what about if it's a single element? So we have to do an elif here. And not there. It has to be under where we had the first if. It was a double lettered element. Now, if it's a single element, then of course we're going to say elif C dot is upper. So if it is just upper, and we have to make sure that C is in the elements, in the periodic table, first of all. So yes, it can be a single lettered element, but is it in the periodic table? So if it is there, and we have to check that what we're going through in this compound, because they could enter a compound that looks like this, and here you can see that there's brackets, that one that opens and one that closes. So we also have to know and detect that this C is not any one of those two brackets, in case if they enter something like that where they have a chemical compound with brackets, we should be able to indicate C is not those two. It can't be any of those two brackets, because we want to be able to store in the C list just the elements and their number of atoms, because that's how we can calculate the molecular weight. So we have to make sure that C is not equal to, so I'm using that not equal to, the opening parenthesis, and then you can say and C is not equal to, so making sure that you don't add the wrong thing into that C list, so you wouldn't be able to calculate the proper molecular weight. So if that's the case, if the uppercase is, we've now done the checking. If the first letter, sorry, is an uppercase, and it does exist in the periodic table. That's why we said C in elements.all symbols. It does exist in the periodic table, so it is valid, but we also have to make sure, but it is not a closing or opening parenthesis. It is actually an element. So just that extra making sure is important. And then we also will count it because it is also counted as an element that is part of this compound. And remember, we said this program is not intended to, calculate the molecular weight for more than 3 elements in a compound. So this count is helping us make sure to do that. Now we're also going to have another elif in case if C is detected as a space, which should not be the case because there shouldn't be spacing when entering a chemical compound. So if that happens, the system should also detect it. And make sure you put 2 equal signs here because you're comparing. And so the system should detect if space is detected, and it should just print saying invalid and just exit for them to restart again. So here I'm going to copy again my famous red color code that I always like to use. I'm going to copy, I'm going to paste it in here, and then I'm going to come down here and I'm going to print a message saying invalid entry. So invalid entry. And of course, I would like to use that X sign. Yeah, there it is, the one I wanted. And then you can then direct them to restart the program again. So time.sleep, do the same thing we just did before. And then you can print a message and ask them, please restart the program. So because they've kind of like entered something with space and enter the correct chemical compound. Yeah, could we change this to chemical compound because we're dealing with compound here, not elements. So if you can just change it to chemical compound, that was a suggestion from AI, but it should be enter the correct chemical compound, not chemical element, because we're calculating the molecular weight or the molecular mass for a chemical compound. And then I'm just going to exit, which would just force close the console for them to restart the program again. So that's for the part of checking and splitting and determining, basically just determining which one of the elements in the compound is a 2-letter element or a 1-letter element, and if there is even space that is detected when the compounds are or the compound is entered. Now we're going to come to the part where we actually are going to check to see if the count is greater than or equal to 1, less than or equal to 3, because we're not accepting more than 3 elements in the chemical compound. So that's really important to check as well. So as you can see, I'm putting make sure your next line indentation is on the same line as the if user selection and the while loop. They have to be on the same line. And here we're going to just say if the count is greater than or equal to 1, right? And the count is less than or equal to 3. This means that it's valid, of course, because we're accepting 3 elements. So accepting, you can write it here so you know what's happening. 3 elements only in the chemical compound that they enter. So chemical compound entered, right? And then, of course, afterwards, if you check all of that and you find out that the count is between 1 to 3, it means it's valid. Now you can go through, now we're in the process of going through again the chemical compound that they've entered and again splitting out the element and this time the number of atoms and saving it in that C list that we created in the beginning, so we can use that C list to be able to calculate the molecular weight of this chemical compound properly. So we're going to do again a for loop. So for, I'm going to say A in compound. You can basically use any letter you want. So we're going through again, as I've mentioned, to check and make sure that, what they're entering is valid, and it's not valid, but it is splitting off the chemical elements and the number of atoms, because we have to make the system smart enough to know that if there is a number in front of the element, then that represents the number of atoms of that element. Hence, we have to multiply that number with the atomic mass of the element that precedes it. So here we're going to say if A, we're going to start because A is the one going through every single character in this chemical compound. So if A dot is upper, so if it's in uppercase, and then again, we're going to check if the second letter is in lowercase, so compound dot index, right? And then we're going to open parenthesis and say index of A plus 1 because we want to be able to get the second element. And then is it lower? Because if that is lower, again, as we've said, it is then, of course, a two-lettered element. So that's just a side, but our main concern here is also checking that the next thing to the first letter in the chemical compound is not a number. So because if it is a number, then we'd have to save that number along with the element in the C list so that we can be able to use that number to multiply with the atomic mass of the element. So here we're going to say and as well. So and, the compound, again, the second letter in the element, so compound. So we're just going to write compound dot index to find the index again of A plus 1 to get that second letter. And we're saying if that second, not letter, but we don't know what it is, whether it's a letter or number, we don't know. But we're saying if that, whatever it is, character in the chemical compound is not in numbers, because if it is in numbers, which you'll see, we're going to do a query for that or an if statement for that. So if it is in numbers, then we would have to split it and also save it because we want to be able to save it as the number of atom of that particular element. So here you can see if A dot is upper, that means if the first letter is in uppercase, and we see compound dot index of A plus 1 dot is lower, that means if the second thing that follows the first letter in uppercase is in lowercase, which means then you can see we have an element together. And we're making sure that the second thing is also not in numbers. And if you remember, we created this numbers list, which contains all the numbers that we're going to use to transform into a subscript or convert into a subscript. So we're checking to see if it's not in numbers. That means what we have to do is we have to join it. And of course, join it together, join the two of them together again. So that means the first element and the second element, but this time adding it into that C list. So remember that the first time we're not repeating things. If you think we are not here, because here we were trying to make sure that they do enter, and we're trying to make sure we're validating the elements that are in this chemical compound, making sure it's either a two-lettered one or a one-lettered element. But here now we're starting to split those elements and their number of atoms in separately so we can be able to save them in that C list and use that C list to calculate the molecular mass with that information. So here we're doing the splitting part. So if that's the case, as I mentioned, then of course we're going to come down here. I'm going to use the join 1 now because we can't use the join. We've already used it. So join 1 is equals to join 1. And then plus the A, which obviously is the first letter. So the join 1 is just acting like a glue, joining the first letter and the second letter together so that they're saved as an element inside of the list that we're going to be creating. So here is A plus the compound index. So again, it's the same thing, just finding the index position and of finding the element of that index position of A plus 1, which means what comes after A. So that's an A, remember, is the first chemical element in uppercase. So after that, you just come down here and you've joined that chemical element, that's the first one in uppercase, with the second one. And then here you can just do a join as well. Oh, we can actually use the first join that we used in the beginning. So we used the first join in the beginning that was here, which was called join. And so we can actually use it here as well. So that was like the first one we used in the beginning. We used join. So what we will do is I will just do something as join 1, or we can leave it as join 1 and then just come here and do that join that we've already used equals to A, which is the first element of the chemical compound in uppercase, plus the second element in lowercase, of course. So that's just joining them together. And now we're going to save that into our C list that we created at the beginning, which would just now start saving the elements and their number of atoms. So we're going to do that right here. We're going to say C underscore list dot append, and that's because we want to append the join, which is basically just joining the uppercase and the lowercase letter, making it into an element. And now we're going to do the same thing again, where again we're going to check if the first letter is in uppercase and the second, and there's no second letter. So this was the first check here, was exactly the check we did at the top, which is just checking to make sure that this is a two-lettered element. But now we're going to do the part where, what about if it's a one letter, just exactly of how we verified it before. So we can say elif again, if A dot is upper, okay, and then we open parenthesis, and then A is, we actually check that it is in the chemical or the periodic table, so we don't make any mistake. So the system doesn't make a mistake, making sure that A is in the periodic table and it is not a symbol of any kind. So we can also add it to the C list. And remember how we add things to a list, we use the append, dot append, and you can see I'm appending with this join right here. So we add all of that to the C list, and we can be able to now add the numbers as well, which is their number of atoms, so we can properly calculate the molecular mass. So what we're going to do here is we're going to use the join, just as we've used it to join the first and second letter in the if statement above. We're now going to use the join to join just the A here in this case, which is just the single letter, since this is a single letter detected. And then we're going to add that, of course, to the C list by saying C list.append, and then we're going to put that particular letter, which is going to append. Or you can put join as well, depends any one you want. It will just append that letter to the C list. And then we also have to indicate and also include, if you want to be able to include this as well, just to show the user, or if you want to just split everything. Remember, the idea here is to split everything and save it into a list. But then afterwards, we're just going to concentrate more on the elements and the numbers, because that's what we will use to calculate the molecular weight.